Behind every single app you use, every website you visit, there's this invisible army of people making sure it doesn't just fall apart. That whole process is software testing. And today, we are opening up the playbook they use to hunt down all the glitches and gremlins that could ruin your day. So picture this. You've been searching for an hour, you've found the perfect thing, you've put in all your details, you hit that big buy now button, and boom, error message. Your order failed. We've all been there, right? It is so frustrating. Well, preventing that exact moment is what this is all about.
So here's our game plan. First, we're going to dig into why software breaks to begin with. Then, we'll lay out the master strategy for actually finding those problems. After that, we'll see how testing is done in layers, from the tiniest piece of code to the whole system. And finally, we'll look at the different ways a tester can view the code, which changes everything.
All right, let's start at the very beginning. See, to stop things from breaking, you have to understand the anatomy of how they break. It's not just some random glitch. Nope, there's a very specific chain of events that leads to disaster. And it all starts with a bug. And what is a bug? Well, at its core, it's just a human mistake. A developer, probably under a lot of pressure, makes a little logical error while writing the code. That's it. That's the seed of the problem. That bug then creates what we call a fault. A fault is basically the bug just sitting there in the code, dormant. Think of it like a tiny, invisible crack in a bridge, just waiting for the right amount of stress to show itself. An error is the moment that fault gets triggered. The software is running, it hits that faulty bit of code, and suddenly it does something it wasn't supposed to do. Maybe it calculates the wrong shipping cost, or it can't find your city in its database. This is the first time the problem actually rears its head. And all of that leads to a failure. Now, this is the part you see. This is the part that makes you mad. The error is so bad that the software just gives up. It can't do what you ask it to. Your online order fails. That's the final, frustrating outcome from that one tiny little bug. So why do these bugs happen in the first place? Well, it's usually not just a simple typo. The real world is messy. Maybe the initial instructions were vague, or the software is just mind-bogglingly complex. A lot of the time, it's crazy deadlines or code that's hard to understand, which can cause even the absolute best developers to make a mistake. Okay, so knowing why things break is one thing, but actually preventing it, that's a whole different ballgame. You can't just randomly click around and hope for the best. You need a strategy. You need a master plan to hunt down those bugs before they ever get to you. And the heart of that strategy is something called the test plan. And let me tell you, this is way more than a to-do list. It's a serious document that lays out exactly what we're going to test, how we're going to test it, and maybe most importantly, what done actually looks like. This is what makes testing a science, not just an art. Let's bring this back to our shopping app. A good test plan makes everything crystal clear. The scoop tells us we're testing the login and checkout, but we're going to ignore the admin pages for now. The environment tells us exactly which browsers and operating systems to use. It even has exit criteria, which is a fancy way of saying this is how we know we're finished. And it even plans for things that could go wrong, so testing doesn't grind to a halt.
Okay, so you have this master plan, but you don't just run it all at once. That would be chaos. Instead, professional testing happens in layers. You build up confidence, starting with the smallest, tiniest piece and working your way up to the entire system.
There are 4 main levels here. You start with unit testing, then integration, then system, and you finish with acceptance testing. The best analogy is building with Lego. First, you check each individual brick to make sure it's not broken. Then you check how 2 bricks snap together. Then you step back and look at the whole castle you built. And finally, you ask your friend if they think your castle is cool. So level 1 is unit testing. This is where a developer takes the smallest possible piece of the app, like just the add to cart button, and tests it completely by itself, in a vacuum. Does this one tiny component do its one specific job correctly? Next up, integration testing. This is all about making sure the different pieces can actually talk to each other. So we know the add to cart button works on its own, and we know the shopping cart icon works on its own, but when you click the button, does the little number on the icon actually go up? That's integration. Now we zoom way out for system testing. We're not looking at tiny pieces anymore. We're testing the entire fully built application, all working together. And we're looking for bigger things like performance and security. Can 1,000 people all try to check out during a flash sale without the whole thing crashing and burning? That's what system testing is for. And at last, we get to the final check, acceptance testing. Does this thing we built actually solve the user's problem? This usually happens in 2 stages. Alpha testing is done internally by people inside the company. Then comes beta testing, where it's released to a limited number of real users out in the wild to see how it holds up in the real world. All right, so we have our plan, we have our layers. The last piece of the puzzle is perspective. The way a tester looks at the software completely changes how they test it. And there are basically 3 main points of view they can take. The 2 big ones are best explained with a car analogy. White box testing is the mechanic's view. The tester can pop the hood, they can see the engine, they know how all the wires connect because they can read the actual source code. Black box testing, on the other hand, is the driver's view. You have no idea what's under the hood. You just know that if you turn the key, the engine should start. You only test the inputs and check for the correct outputs. And you guessed it, sitting right in the middle is gray box testing. This is a hybrid. The tester knows a little bit about what's going on under the hood, but not everything. This approach is super useful for today's apps, where you need to know how your app connects to, say, a credit card processor, without needing to know every line of the processor's code. But after all of this, after all the plans and the levels and the different techniques, we have to face one fundamental truth, and that is, testing can only prove the existence of errors, not their absence. You can never ever be 100% certain there are no bugs left. You can only be confident that the tests you thought to run didn't find any. Which kind of leaves us with one final thought, right? The next time you're online and you click that Buy Now button, what are you really trusting? Well, you're not just trusting the website. You're trusting this entire invisible, complex process of bug hunting. You're trusting the playbook and a whole lot of people you'll never meet, whose hard work just works.